in the part catalog list, select Structure. Click the U.S. Imperial Structure Catalog folder, and then click New Chapter. Enter Custom for name, and then click OK. Select the custom folder, and then click New Parametric Part. For name, enter No 233A. Click in the description field, and add outside drop connection to the default description, and then click OK. Expand part configuration and change the following. Right-click Work Planes, and then click Add Work Plane. Click Top, enter Rim for name, and then click OK. Expand Work Planes, right-click Rim, add Geometry Point. Click a point near the center of the yellow rectangle, and then press ESC. Right-click Work Planes and then click Add Work Plane. Click Right, enter Vertical Axis for name, and then click OK. Click Save Part Family. Click Yes. Expand Modeling Work Planes, right-click Vertical Axis Set View. The current view in UCS is set to match the work plane. Right-click Vertical Axis, and then click Add Geometry Line. Create a line with 5 segments on the work plane. Begin by snapping to the node of the reference point on the rim work plane and use ortho to make it easier to draw a straight line. Make the segments about 24 units long. A line geometry object is shown in the drawing. This line represents the vertical axis of the manhole. Each segment represents a component of the structure. Starting from the top, the segments represent the frame, the cone, and the last 3 segments represent the barrel. You will use the extra vertices to place the incoming dip T and the drop 90 degrees elbow in the next steps. Use the Add Geometry Line and Add Geometry Arc to draw the schematic of the drop assembly. Don't worry about making the parts perfectly meet. You will use constraints to make the geometry match up properly. Make the 2 horizontal lines that connect to the vertical line about 36 units long. Next you will establish some constraints to keep the components of the profile in the correct location relative to one another. Right-click Vertical Axis, add Constraints Parallel. Select the bottom line segment of the manhole center line, and then click the segment directly above it. The bottom 2 segments are now constrained such that they are parallel to each other. Repeat the process, working your way up the center line, constraining adjacent line segments to parallel. All segments representing the center line of the structure are constrained to be parallel to one another. Right-click Vertical Axis, add Constraints Perpendicular. Select the bottom segment of the structure center line and the lower horizontal line. Repeat for the upper horizontal line. The lower and upper horizontal components of the drop pipe are constrained to perpendicular to the structure center line. Right-click Vertical Axis, add Constraints Parallel. Select the bottom line segment of the manhole center line and then click the vertical segment of the drop pipe. The vertical drop pipe is constrained to parallel to the structure center line. Right-click Vertical Axis, add Constraints Coincident. Click the point at the top of the vertical drop pipe, and then the left end of the upper horizontal line. This positions the rectangle so that its center is located at the fixed point. Right-click Vertical Axis, add Constraints Parallel. Select the right upper horizontal segment, and then the left upper horizontal segment. The 2 upper segments are constrained to parallel. Right-click Vertical Axis, add Constraints Tangent. Select the lower horizontal line, and then the arc. Repeat for the arc and the vertical segment of the drop pipe. The drop pipe bend arc is constrained to be tangent with the horizontal and vertical segments of the pipe. Right-click Vertical Axis, add Dimension Distance. Click the bottom and then top points at the ends of the top segment of the center line. Click a point to set the location of the dimension. A dimension named LENA1 is created for the line segment representing the frame height. Repeat these steps for each segment of the center line, starting at the top and ending at the bottom segment. Dimensions named LENA2 through LENA5 are created for the center line of the structure. Add a distance dimension to the lower horizontal line by picking the points at each end. This represents the distance from the structure center line to the start of the elbow. This is used to ensure that the drop stays on the outside of the structure. LENA6 is created. Right-click vertical axis, add dimension diameter. Select the arc that represents the elbow. Click a point to set the location of the dimension. BDYD1 is added to the arc. Add one final length dimension to the left upper horizontal line segment. LENA7 is added. Click Save Part Family. The part is saved. Right-click vertical axis, add profile circular. Click an open area near the top right of the vertical axis to define the center, and then click again about 12 units away to define the diameter. A circle profile is drawn. Right-click vertical axis, add dimension diameter. Click the circle drawn in the previous step. Click a point to set the location of the dimension. BDYD2 is created for the frame diameter. Expand vertical axis. Right-click circular profile, rename. Enter frame cylinder diameter. This will make it easier to work with this shape later. Next, repeat the previous two steps to create and dimension the top of cone profile with a radius of about 18 units, and the barrel profile with a radius of about 24 units. The top of cone profile is drawn and dimensioned with BDYD3. The barrel diameter profile is drawn and dimensioned with BDYD4. Next, create and dimension the drop pipe profile. Right-click vertical axis, add profile circular. Click an open area to the left of the upper end of the vertical axis to define the center, and then click again about 6 units away to define the diameter. Add a diameter dimension to the pipe profile. The pipe profile is created and dimensioned with BDYD5. Rename the three circular profiles to cone top diameter, barrel cylinder diameter, and drop pipe diameter. Renaming the profiles will make them easier to work with later. Click Save Part Family. Right-click Modifier, SAD Path. When prompted for path, select the top line segment, the segment dimensioned LENA1, then select the frame cylinder diameter profile, the circle dimensioned BDYD2, for the start profile, and select it again for the end profile. The frame cylinder diameter profile is applied along the path, length, of the top line segment. Change the view to SE isometric to get a better view of the path. Change the view back to right. Repeat the add path command for the cone segment. For the start profile, select the cone top diameter profile, dimensioned with BDYD3. For the end profile, select the barrel cylinder diameter profile, dimensioned with BDYD4. Repeat the add path command for the remaining 3 line segments. Use the barrel cylinder diameter profile for both the start and end profiles for each of the 3 segments. Change your view to SE isometric to see the part in 3D. Change view back to right. Next, you'll add paths for the drop pipe assembly. Right-click Modifier, SAD Path. Select the lower horizontal segment for the path and the drop pipe diameter profile for the start and end profiles. Add path for the curved elbow. When the Enter Number of Path Segments dialog box is displayed, verify that Do Not Segment Path is checked, and then click OK. Then add the path modifier for the vertical segment of the drop pipe. Use the drop pipe diameter profile. Finish the drop pipe assembly by adding paths for the upper segments. Start with the right upper segment. Switch to SE isometric view. Switch back to right view. Next, you'll add paths for the drop pipe assembly. Right-click Modifier, SAD Path. Select the lower horizontal segment for the path and the drop pipe diameter profile for the start and end profiles. Add path for the curved elbow. When the Enter Number of Path Segments dialog box is displayed, verify that Do Not Segment Path is checked, and then click OK. Then add the path modifier for the vertical segment of the drop pipe. Use the drop pipe diameter profile. Finish the drop pipe assembly by adding paths for the upper segments. Start with the right upper segment. Switch to SE isometric view. Switch back to right view. Right-click Modifiers Boolean Add. When prompted to select objects, select the top 2 barrel segments, and the upper 2 horizontal pipe segments, and then press Enter. Right-click Modifiers Boolean Add. When prompted to select objects, select the upper horizontal pipe segment, and the vertical pipe segment, and then press Enter. Switch the view to SE isometric. Next you will set the placement point for the part. Save the part. Click Save Part Family. Right-click Size Parameters, add Edit Configuration. Click New. Add the following parameters, clicking New for each. Click Save Part Family. Right-click Model Parameters, and then click Edit. Double-click in the equation column next to each of the following, and set the equation for each parameters as shown below. Right-click Size Parameters, and then click Edit Configuration. The Edit Part Size dialog box is displayed. Locate the SRS column, click Constant, and change it to Range. The SRS parameter is now formatted as a range of values. Click the drop-down arrow button next to Parameter Configuration, and select Values. The view is changed to show the value of each parameter. Click the cell in the SRS column, and then click the Edit button on the Edit Part Sizes dialog box toolbar. The Edit Values dialog box is displayed in the following table. Make the following additional edits. Edit the equations and descriptions for the Lena number parameters as shown in the following table. Click Close. Change to SE Isometric View and note the changes to the geometry of the structure. Change the 4 circular profiles so they are not visible by right-clicking on each and then clicking Visible. The circular profiles are no longer visible. Repeat the previous step for all of the dimensions. Change view to SE Isometric and examine the part. It should look like the following image. Click Save Part Family. Close out of the Part Builder environment, and then reopen the part. Right-click Size Parameters, and then click Edit Configuration. Change the data storage type to List for the following parameters. Click the drop-down arrow button next to Parameter Configuration, and select Values. Select the 4.000 in the WTH column, click the Edit button from the Edit Part Sizes dialog box toolbar, and add the following values. (4.0, 6.0). Click OK. Repeat the previous step for each of the following parameters. Click the drop-down arrow button next to Values, and select Calculations. Double-click in the cell in the PRTSN to open the Calculation Assistant. Change the precision to 0. Click in the text box, right after PRTD, and press the space bar. From the Insert Variable list, select FTH and then click Insert. The FTH variable is inserted into the part size name. Enter in floor after the FTH variable. Exclude the quotation marks. Repeat the previous steps, adding variables and text for SCH, SFD, SFH, SID, WTH. The complete string should look something like this. Click Evaluate to see the resultant part name. Click OK twice to close all dialog boxes. Save the part. Switch visual style to conceptual. The part should look like the following. Right-click Model Parameters, and then click Edit. Double-click the equation for SVPC and enter, SFH and SCH and SBPC. Change the visual style to 2D wireframe. Right-click Vertical Axis, add Geometry Point Reference. Click the point in the center of the rim work plane. Right-click Vertical Axis, add Constraints Coincident. Click the top point of the vertical axis, then click the reference point created in the previous step. The entire structure moves upwards so that the rim elevation matches the top work plane. Click Generate Bitmap. Click SE Isometric View. Click OK. A bitmap image is generated. This is the image of the part that is displayed when viewing the part in the part catalog. It is not used when viewing the part in a drawing. Click Save Part Family.